We usually think of mathematical equations as rigid, unbreakable laws. But when physicists pushed a standard set of physics rules to their absolute limit, the math began to shatter, revealing a completely different behavior. This behavior aligns with the core proposal of string theory, the idea that if you zoom in far past atoms and subatomic particles, all matter is made of unimaginably tiny, vibrating strings of energy. There has always been one massive obstacle to testing this idea. Seeing these strings directly would require a particle collider roughly the size of our entire galaxy. Because physical proof remains out of reach, many in the scientific community have dismissed string theory as a mathematical fantasy rather than a physical reality. For over a century, we have relied on Albert Einstein's general relativity to understand the cosmos. His rules describe gravity and govern the large-scale structures of the known universe. But those rules stop working at the Planck scale. This is a measurement limit 19 orders of magnitude smaller than a single proton, where physicists attempt to calculate what happens during extreme particle collisions. When scientists try to use general relativity at this microscopic scale, the calculations stop providing answers. Instead, the equations spiral into mathematical infinities. This failure leaves a gap in our knowledge. At the most extreme energies, our current understanding of how reality works is incomplete. Searching for a way to bridge that gap, theoretical physicists at Caltech and their collaborators decided to stop trying to build giant physical colliders. Traditional physics relies on machines of overwhelming mechanical complexity to smash particles together and observe the debris. But there is a limit to what humans can physically build. To see further, the researchers needed a mathematical approach that didn't depend on mechanical constraints. They utilized a strategy from the 1960s known as the Bootstrap method. Using this approach, scientists refuse to assume any specific theory or model from the start. It works like a Sudoku puzzle. You start with a blank slate, plug in a few basic logical rules that nature must obey, and let those rules dictate the final structure. By stripping away all initial assumptions, the researchers ensured that whatever answer emerged was the direct result of the math itself. The team programmed their mathematical blank slate with two specific conditions. The first is a concept called ultrasoftness. Ultrasoftness requires that when particles meet at extreme energy, their interaction energy smoothly disperses, preventing the infinities that cause equations to fail. The second rule, minimal zeros, dictates the equations have the bare minimum number of points where scattering probabilities vanish. Crucially, no instructions were included about tiny vibrating strings, the force of gravity, or 10-dimensional space. When these simple conditions were finally run through the mathematical models, the raw numbers rapidly began to align. By requiring the math to remain stable at extreme energies, the researchers forced the equations to reveal a specific, orderly framework. This chart reveals the pattern that emerged, an infinite tower of particles, increasing in strict, orderly steps. In the 1960s, Gabriele Veneziano noticed this exact sequence inside early collider data. This math perfectly matches the harmonics of a vibrating string. This is the core of string theory, the idea that all distinct particles, from photons to gravitons, are merely different vibrational modes of these fundamental strings. The requirements of string theory were not assumed. They emerged directly from these basic logical rules. Mathematical emergence is a significant clue, but equations are not a substitute for direct experimental proof in a physical laboratory. However, out of an infinite number of possible mathematical outcomes, only string theory survived these strict logical tests. Human preference did not guide this result. The outcome was dictated by the universe's own baseline logic. These vibrating strings appear as the underlying matrix of space itself, forming the fundamental foundation of the entire cosmos. If the universe must follow these basic logical requirements, then string theory is not just a possibility, but a mathematical necessity.